Hey, having considered the derivative of the product of two functions, it should probably come as no surprise that we are next going to consider the derivative of the quotient of two functions. In other words, start with two differentiable functions, f and g. We're going to try to compute the derivative of f divided by g. You have to be careful and make sure that the denominator is not 0. And all we have to work with is the definition of the derivative. This is the limit as h approaches 0 of the function evaluated at x plus h minus the function itself, all divided by h. We've seen problems like this before, although not in such a general form. In order to make progress, you need a common denominator so that you can add the fractions in the numerator. And in this case, the common denominator is g of x plus h times g of x. And what have I done here? Well, I combined a few steps. First of all, I multiplied the f of x plus h over g of x plus h by g of x over g of x so that it would have the denominator g of x times g of x plus h. And I multiplied the f of x over g of x by g of x plus h over g of x plus h so that it would have the same denominator. And then I was able to add those two numerators to get this expression here over the common denominator g of x times g of x plus h. And then the last thing I did was I said dividing by h here, same thing as multiplying by 1 over h. Rather than having fractions on top of fractions, we may as well look at it like this. And then I used essentially the same trick that we did when we developed the product rule. I added 0 in the middle. In particular, this expression right here, negative f of x g of x plus f of x g of x, is 0, and that's the only difference from the line above to this line here, that adding 0 in the middle. And this lets us factor out a g of x from the first two terms here, and factor out an f of x from the next two terms there. And it's starting to look interesting. In particular, I have this f of x plus h minus f of x. That looks like a piece of a derivative. On the other hand, this g of x minus g of x plus h is backwards, and I would like to fix that so that it was a g of x plus h minus a g of x. A quick algebraic trick will help us do that. What I've done is essentially factored out a -1 from this term here and brought it out there, so that lets me write this as g of x plus h minus g of x. If you distributed this -1 into there, you'd get a negative g of x plus h and a positive g of x, which is just what we've got. So that works. And then I've separated this into two fractions, this one here and this one here, from this one here. And I've separated each of these two fractions into two fractions itself, because you can multiply the denominators and multiply the numerators, and you'll get something that you can add together to give us exactly what we came from right there. And let's make a little room. And then apply the limit laws, and two parts jump out immediately. This part is easy and this part is easy. Those are both the derivative of f and the derivative of g. And then you have to ask yourself about these parts right here. The limit as h approaches 0 of g of x over g of x times g of x plus h and f of x over g of x times g of x plus h. Well, as h approaches 0, the g of x and the f of x stay the same. They've got no h's in them. The only question is, what happens to g of x plus h? And as we did with the product rule, we argue that g is differentiable, so it's continuous, and so we can compute the limit as h approaches 0 of g of x plus h simply by plugging in h equals 0. Which gives us this expression here. And if you've been wondering why I didn't cancel the g of x in the numerator with the g of x in the denominator in this thing right here, then it's simply because I'm going to want to combine these two things, these two fractions, and in order to do that, I'm going to need common denominators, and the common denominator is going to be g of x squared. And writing my two fractions like this, I finally come up with an answer. The derivative of f of x divided by g of x is g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. And this little beauty is what we call the quotient rule. And you say to yourself, How am I going to memorize that? And the answer is, you're going to learn this little ditty. Ho dee hi minus hi dee ho over ho ho, where ho is the bottom part and hi is the top part, no relation. And so we're talking about ho, this ho right here, is the bottom function g of x right here. D hi, that's the derivative of the top function. So the d means derivative. Minus means minus, of course. And then there's hi, that's the top function. D ho, the derivative of the bottom function. That's this part over here. And it's all over ho ho. That's the bottom function squared. Sort of like Christmas in calculus class. Ho dee hi minus hi dee ho over ho ho. Some people like low dee hi, which is understandable, but I don't. I like ho dee hi. You learn it however you like, just so long as you learn it. Okay, we worked so hard on this beautiful quotient rule, we may as well take it for a spin. Let's find the derivative of this function, x squared plus 3x, all over x cubed plus 1. Well, it's ho, the bottom function, d hi, so times the derivative of the top function, and the top function is x squared plus 3x, its derivative is 2x plus 3, minus hi, so that's subtracting the top function, d ho, so times the derivative of the bottom function, and the derivative of x cubed plus 1 is 3x squared, all over ho ho, the bottom function squared. And then if we wanted to, we could do a bunch of algebra to simplify this. I'm just going to leave it like this for now. Often in these quotient rule problems, I will say, don't bother simplifying. You almost always have to simplify all your answers, but all the interesting work has already happened, and if you need to simplify, I'll let you know in a quotient rule problem. Okay, you try this one. Find the derivative of x plus 1 over x plus 2, and I'm letting you know, simplify this one, because it comes out kind of nice when you simplify. Shouldn't take you more than a moment. Pause the video. When you're ready, start it back up. And the derivative is ho dee hi minus hi dee ho over ho ho. That's the bottom, x plus 2, times the derivative of the top. The derivative of the top is just 1, minus the top, x plus 1, times the derivative of the bottom, which is just 1, all over the bottom squared. And when you do a little algebra to simplify, you see that some things cancel, and you end up with 1 over x plus 2 squared. If you like, you could expand the denominator. I don't know that that's any simpler. You could argue one way or the other. I think that it's probably simpler like this, but either way, you could have written it as 1 over x squared plus 4x plus 4, same thing. Try this beauty. The function g of x is equal to 1 over x. We've already found the derivative of this function using the definition of the derivative, but I promised you when we did that we would take the derivative of this function many different ways. Let's try it using the quotient rule and see that we get the same thing. So take a few minutes, should be less than that, take a few moments, find the derivative of this, pause the video. When you're ready, we can do it together. And the derivative is, of course, ho dee hi minus hi dee ho over ho ho. Ho is the bottom, that's x. D hi, the derivative of the numerator. Well, the derivative of 1 is 0, so we have x times 0. Minus hi d ho, hi is 1. D ho is the derivative of x, which is just 1. All over ho ho, that's x times x, or x squared. And when you simplify that, like I probably should have told you to, but you also probably should have seen that it's very easy to simplify, you get negative 1 over x squared, just like we did when we found the derivative of this function using the definition of the derivative. Okay, one last example for you to try, just so you can see how nasty calculus can really get. Whatever you do, don't try to simplify your answer, but take a few minutes and see if you can find the derivative of this function h. When you're all ready, start the video up again, which implies that you will have paused it beforehand, which is what you should do now. Ready, stop. And what's the derivative? Well, it's certainly ho d hi minus hi d ho over ho ho. And the ho part, that's the denominator, that's x squared plus 1. And the d hi is where it gets interesting. It's the derivative of the numerator. Well, the numerator, x to the 5th plus 4x all times e to the x, How do you find the derivative of the numerator? I'll let you think about that. You're absolutely right. It's a product. You have absolutely no choice. You have to use the product rule. So just for the d high part of this, we need the product rule because the derivative of the numerator is a product. So let's see if we can figure that out. First of all, I'm opening a square bracket because it's ho d high, meaning the bottom times the derivative of the entire numerator. And the derivative of the numerator is going to be something plus something else. And I have to be multiplying the bottom by the whole thing. So I'm being careful right now. And it's the derivative of the first times the second. So the derivative of x to the fifth plus 4x is 5x to the fourth plus 4 times the second, so times e to the x, plus the first, which is x to the fifth plus 4x, times the derivative of the second. And the derivative of e to the x is just e to the x. And all we've done so far is the ho d high part. Here we have minus high minus the numerator, d ho times the derivative of the denominator, the derivative of x squared plus 1, just 2x. And this is all over ho ho, the denominator squared. And since I said that we don't have to simplify anything, we are all done. Moral of the story, and the reason I gave you this problem is, sure, you might have to use the product rule in computing the quotient rule. Could be the other way around as well. There's a place for, in the quotient rule where it's the derivative of some function. How do you take the derivative of that function? Well, depends on the function. However you need to take the derivative of that function, that's how you take the derivative of that function. And if it required the product rule like you did here, then that's what you have to do. Okay, that was the quotient rule. There is, of course, a homework. Take a stab. Don't forget to enjoy it. Looking forward to seeing you in class. Bye.